the mining value chain is estimated at around $2 trillion. And there's a lot of variation in that. And there's hidden livelihoods within each of these numbers. So when you think about steel, of course, we know that there's a lot of value in terms of financial value. But if you look at gold, the financial value is considerable, but the livelihood value is perhaps even greater in terms of how many people depend on gold for their livelihoods. But then from a sustainability perspective, when we look at gold, there are some really problematic questions which come up. So this is the kind of conundrum that we're dealing with in the mining industry and its transformation. And I'll go through that later. And gold, for example, in terms of its environmental impact and the amount of wastes that are produced is much higher than many other metals. And I've heard even in your wonderful university here, there isn't that much research on gold because you need very specialized labs for cyanide, for example, which is used in gold processing. So you're constantly balancing the environmental and the social. On the social side, gold employs more people than any other metal, especially because of artisanal gold mining. But on the environmental side, it has other concerns. And also from the point of view of the circular economy, it raises some interesting questions. So the mining value chain, you have to look at it with a degree of nuance, which is often missing when this is just approached by one disciplinary perspective. And that's what I'm aiming to do, is to give you a multiple disciplinary perspective on this. Now, if you think about waste analysis, just in terms of the metals and mining sector, this is some recent work by the consulting firm Accenture. And it's giving you a sense of where in the sort of the life cycle of materials, where the waste analysis takes us. And if you start off in terms of engineering and design, clearly, you have very low waste generation. And then you've got the extension, the extraction, and the processing, where the dark purple shows you a very high degree of waste generation, just as an example. And I'm using waste as an important metric for understanding the impact, because waste gives you in many ways an indicator of efficiency.
Thank you very much for all your help. Have a good one. Thank you.
And in an ideal world, of course, we would want waste to be obsolete, right? Of course, we know thermodynamically that's not entirely possible, but that is that kind of asymptotic goal we all want, right? So that's why I use waste as an important indicator in this regard. And then you have logistics, and then manufacturing. Suddenly, you've got again a more purple impact there. And then, of course, consumer use and reverse logistics and so on. And then you get sort of the circle of closure, perhaps, that would come forth. So this is how we should be thinking about mining as well, from cradle to cradle, as we say in the language of life cycle assessment. And this is where a lot of the mining industry needs to be thinking much more in a systems perspective. And I feel as though many times they just use this diagram just internally within their operations, and they're not looking at it at a much larger scale. So many times when I go to mining industry meetings, when they think of a circular economy, even they're often thinking about just waste cycling within their own operations. But here I'm talking about a much more macro level issue that we should be concerned about. So this is from a paper that was authored by some of our research teams at the University of Queensland, where I used to be based for 5 years. I was in Australia directing a research center there. And this was one of the first papers actually written on the role of mining in a circular economy. And this cartoonish kind of diagram, I think, is a very easy way for us to consider where those cycles could take us, right? So if you've got Consumption itself, we often talk about the reuse and repair. There's the remanufacturing aspect that gets often missed. So it's a much bigger design problem than just looking at the waste circulating itself. And that's how we need to think about these issues from a systems perspective. And on the International Resource Panel, for example, we have been very concerned that many of these intermediary issues get missed, like remanufacturing. And remanufacturing has enormous potential for delivering sustainability outcomes. So in fact, 2 years ago, we published a specific report through the International Resource Panel to focus on remanufacturing because of all of the positive impacts that remanufacturing could deliver. And then, of course, with recycling too, we have to be thinking in terms of upcycling and downcycling, right? Whether you are actually using the materials with additional value or you are degrading them to points where they're not going to be as useful. And that's where a lot of those metallurgical processes, all of those things become important. And then there's the other question, of course, is the economics in there, whether there will be economies of scale that will allow us to bring them back into use, or whether we need to subsidize. Is this an example of where a positive subsidy would be important? So for example, we were having a discussion earlier today about lithium batteries. You know, lithium ion batteries, very important technology in multiple ways for green energy transition, but certain kinds of batteries may not have the economic incentives for recycling currently because of various factors. And so would that be a place that you actually bring in the environmental benefits as a means of leveraging other kinds of either public sector engagement or other forms of incentives that would make that appropriate, because you're looking at the total global environmental benefits. So it's a much bigger conversation that the mining industry usually is not that attenuated to, but they are increasingly becoming more engaged with, because there are these larger issues with reference to critical metals and conversations about the green transition and so on. Now, this is an example from one particular area where the mining industry has started to take much more interest in a circular economy. This is from the recycling of catalytic converters for platinum group metals, right? So as many of you would know, the platinum group metals are excellent catalysts, and currently the largest use of them is in catalytic converters. And because they are very easy modular products, it's easy to recycle them. And so a company like Anglo American, which is one of the world's larger platinum producers, has gotten into the recycling business more so. Though traditionally a lot of mining companies have not been as involved in the recycling business, except for in certain sectors like aluminum, where there were certain structural factors which led to that taking place. But this is an area where I see promise, that there is an interest in having this kind of approach. So this is, it's just a simple process, relatively speaking, but still involves some important chemical activity. And of course, if you're doing a life cycle analysis, you have to think about those total systems-wide impacts as well. So we see that potential now, especially that platinum group metals are also going to be important for the hydrogen economy, because hydrogen fuel cells will be requiring many of these metals as well. So there is this opportunity for the mining industry, especially in these kinds of sectors, to bring in a circular economy approach and also link it to the green transition. So this is how they would link into hydrogen technologies. This is a diagram from Anglo American, actually, just to give you an example. Anglo Platinum, they have published an excellent sustainability report, actually, I might say, and I'm not saying this with any bias particularly. I try to review various sustainability reports of companies, and they refer to it as an ESG report. It's particularly detailed in terms of the metrics. And this is just an example from their most recent one, where they're looking at platinum and iridium catalysts and their use for the hydrogen economy, and how they're going to connect with this in terms of long-term delivery. Now, people may ask, well, where would hydrogen fit in with the mix of other kinds of metals which we might need for batteries? Any thoughts on where hydrogen would be more used? Any of the students, compared to electric cars? Where would hydrogen be most likely to be used? Yes? For trucks, yes, absolutely. Trucks would be one area, though they are making batteries for trucks as well. But the most high impact use will likely be in shipping and aviation. And that's where there's going to be that benefit of hydrogen versus other kinds of technologies that will kick in. And that's what at the UN level we are looking at when we do these large assessments of how to think about developing countries transitioning to different kinds of renewable technologies. Hydrogen, I think when it comes to commercial cars, electric cars have kind of won the race with hydrogen. But when it comes to these large transport vehicles, especially for shipping, which is a very dirty industry currently from a carbon perspective, because a lot of it involves diesel, there will be the hydrogen imperative, because you can't have such huge heavy batteries, similarly with aviation, right? So this is another paper that looked at, if we were to think about a closed loop supply chain for rare metals, particularly, what would this entail? And it's a nice little diagram, which I think is instructive, because it brings in this question of a stockpile also. When we think about economic cycles and what makes it attractive to mine versus recycle, we are very much short-term oriented, right? So this is the other challenge we have when we're making environmental decisions, is that we tend to use a discounting factor in doing our cost benefit analysis, right? What do we mean by discounting factor? You discount the value of future benefits compared to the present, right? Why would you discount the value of future benefits compared to the present? Because we do not know the future. So you cannot, at some level, you should say maybe we should value the future more because resources will be more scarce in the future. But that's now not how sort of economic rationality works. You actually discount the future because you don't know what's going to happen. So what ends up happening is with short-term decision-making, when you do not know future benefits, when you do accounting that companies have to do, they often have very short-term decision-making in those ways. So stockpiles are an interesting way whereby you can have some calibration of supply with reference to what is most ecologically efficient as well. So here, they're basically laid out the spectrum from no stockpile to stockpile, and they've got recycling levels low to high, and they basically say what are the different sort of planning scenarios that play out. And you can read the full paper for more details, but it's just an interesting way again of thinking about long-term planning in this way. And from the same paper, this is what they've laid out in terms of how you might measure the different levels of impact. And they put government in there because you really do need the public sector involved. This is an example of a public-private partnership approach to dealing with these kinds of challenges. And this is what we call sort of constructive capitalism, where you bring in the government only where it's most needed. Whereas to think about the greatest social benefits when externalities from economic decision-making might otherwise lead us to what we call market failures, right? So this is how you end up with hopefully an optimal outcome for the social system, which is what we want from a sustainability perspective as well. And the customer is there, and you try to, of course, minimize the disposal triangle at the bottom. And you can, do this kind of analysis. So this is something that I would say, as especially mining companies become much more concerned about their sustainability profiles, And as they become more involved in a circular economy, where they're thinking about their recycling sector, they're thinking about larger design issues, they may in fact be getting more vertically integrated, where they are looking at products downstream. And that has been the case with many companies. Historically, they were more vertically integrated. Of course, Alcoa is a classic case, which is a highly vertically integrated company. Again, with aluminum, structural reasons why it happened with aluminum. My next project is actually going to be about aluminum. So it's very center stage on my mind. But that can happen with other metals as well, right? It's a matter of realizing that long-term ecological vision. And it's in some ways no surprise that aluminum is one of the most recycled metals now. I mean, there are some other factors, chemical reasons for it too, but it's not necessarily just the chemical reasons which have allowed that to happen. Okay. Now, the other thing is there are also financial tools which are available, and there are these specific kinds of funds which can keep track of global stockpiles that exist of metals with these kinds of metals. So this is from Bloomberg, and there's this kind of product, it's called ETFs, which are essentially keeping track of the global stocks of different kinds of metals. So these are estimated stockpiles held by market players or holdings in palladium. This is for palladium. You can have this kind of a mineral financing and assurance mechanism, which can also help us to calibrate what it is to be involved in sustainable mining operations and making decisions on when to mine, when not to mine as well. But it's still not as widely used and available as we may want it to be. Now, gold presents a real challenge. I told you I'd come back to gold. Why? Because from an ecological point of view, we should not be mining gold at all. Why? Because we have actually mined more gold than there is in terms of the known reserve base currently, or not even reserve base, actually it's a resource base. If you economic geologists would know the difference there. This is actually the resource base, which is not just economically viable reserves which you can extract, but what is known to be out there. We've got about 54,000 tons, and what is estimated is that we have above ground over 190,000 tons. And a lot of that gold is available for reuse, even one would say, right? Because it's in bank vaults. It's going back to the time of the gold standard. When we used to keep gold, we have it in Fort Knox. We have all this gold, which is being used essentially just in this sense of security that we are getting from it, which is no longer linked to the original financial purpose for which it was intended. So one could suggest that, in fact, if you were really thinking about a circular economy and you're thinking about the demand for gold, there is really no reason why we would be mining gold. It's a provocative statement to make, but it's a very factually accurate statement to make because for one thing, most of the use for gold is jewelry, which you, from an environmental point of view, people would say, well, it's not a critical metal in the same way as some of the other metals. Yes, some small amounts of gold are used in electronics and all, but in volume amounts, there's a very small amount of it. And gold is eminently recyclable. I mean, that's why it was originally valuable, right? That's why the pharaohs were burying their kings in gold, because there was a sense that it would remain as such. So gold from that chemical perspective, because it doesn't oxidize easily, is also very eminently recyclable. And yet we know that gold is an extremely important metal for mining. And the only rationale for it is an economic rationale that's linked to livelihoods, really. Otherwise, it does not really, and the decision that countries have made to keep those reserves in various ways. as well as to some degree, one may argue in terms of the privately owned gold, which is used for an asset base, whether it's in jewelry and so on. So it's a tricky one, because if you really want to go the sustainability route, it's the one which is the low-hanging fruit from the point of view of sustainability metrics. But then there's this other distortion. This is from a paper that we published in 2017 in Nature, where we looked at mineral governance needs. And this analysis looked at exploration investment. And there's a huge distortion here, because more than a third of the gold in 2015, more than a third of exploration investment was going into gold. So if you go to the PDAC meetings in Toronto, you will see gold is disproportionately represented, right, in the companies which are there. And that's an economic reason, but it's a distortion from a societal point of view, because you should be having more, tellurium and palladium and platinum and other companies with these critical metals, which are so important for the green transition and so important for society and so on. But you do not have that because the economics are not there to justify it as much, right? So, and there was a time when gold was almost 60% of the total exploration investment in the 1980s. So a huge distortion is going on there. And that's something we need to be attentive to. The main rationale for this is that we need the economic rents and the livelihoods generated from gold. That's the only rational reason from a social perspective, apart from the individual economic incentives. So a country like Ghana would say that they get enormous amounts of revenues through gold and for development purposes. And that makes sense. Certainly countries like which rely on gold for that makes sense. Or you could say that artisanal miners, and they're estimated to be about 20 million artisanal gold miners, more than any other metal, that livelihood imperative is why we should still be mining gold. But then you have to keep asking yourself the question of whether that is necessarily the most efficient long-term livelihood strategy, or whether we should be thinking of other transitions. So it's a complicated area in that regard. Now, from a circular economy perspective, we need to start thinking also about where the metals are coming from if we are going to create some kind of branding around giving more importance to recycled metal. And there has been a proposal to have much more of this kind of blockchain record of tracking of sources of metal and where they're coming from. This diagram is coming from an area of the mining industry, which probably your university is not that involved in, and not many places are, and that is the deep sea mining area, right? So here on the left, you see that polymetallic nodule is written there. And the argument that some of the deep sea mining companies are making is that we want to, and this is very unusual, it's really quite transformative for the mining industry approach. They say that they only want to mine enough metals from the deep sea so that they can have a stockpile that is in the batteries of electric cars that they can be recycled. And then they would stop mining and they would go into the recycling business of batteries. So if you look at the business plans of some of these companies, that's what they're aiming for, because they recognize that you do not want to create a situation where you are just mining from the deep sea because of other concerns about environmental vulnerability. And what they would argue then is that if you're able to have a tracking of the metal that's coming from different sources, then you would be able to also say that this is more sustainable and so on and so forth. Now, we have tracking technologies that have been developed for like diamonds, especially for other minerals. We use those for trying to understand gemstones. People use a lot of tracking efforts because the value of a gemstone is origin determined. So for gemstone mining, there are labs which just specialize on telling whether your ruby came from Myanmar or it came from Madagascar. And that's for economic reasons, because the value of a ruby from Madagascar is going to be different from Myanmar, or an emerald from Colombia. And that's all about branding. I mean, it's all in the eye of the beholder. There's nothing inherently better about a ruby from Myanmar. It's just that people have branded it as being pigeon blood red. Now, that's not true with commodity metals, right? Gold is gold is gold. There's a rose is a rose is a rose is a rose. Same with that. It's a different approach that way. However, if you say that that gold is coming from a responsibly sourced mine, then tracking it would make sense, because the consumer may say, well, we want gold which is responsibly mined, or we want this metal which is coming from this source. And so that is increasingly something that is being done. You know, companies are doing that with copper. Rio Tinto did that like 20 years ago. There was the Eden project in the United Kingdom, you may be familiar with, which was an old quarry in Cornwall. They restored it and made it a tourist attraction, where they've got these big domes and they've got greenhouses inside, and people go and visit. One of the biggest tourist attractions in UK now. And the copper in that setup, Rio Tinto supplied it completely from the Bingham Canyon mine, and they were able to track it, that all that copper came from that one mine, right? So it is possible to do, but I think now we can, but they had to do it with a lot of care in terms of each individual shipment and all. If we can do it at a much larger scale, using blockchain, for example, it may be something that is more secure. Now, blockchain may not be necessary in each kind of commodity, but in certain cases, if you're concerned that someone is going to tamper with the tracking, then blockchain makes sense. If you're not worried about that, then blockchain doesn't make sense. But this is just, sometimes blockchain can be gimmicky also. People get on these technology bandwagons. So you have to know where you're investing, but it's still something to consider as useful potentially. Now, coming back to the deep sea case, this is a paper which we have just got accepted in the Journal of Industrial Ecology. So it'll be coming up soon. In January, it should be published. And basically, we're looking at different aspects of ways to compare metals. And this is looking specifically in terms of waste. For example, this paper, but the diagram shows you like how you can use LCA methods to consider the impacts from terrestrial versus oceanic minerals. And ultimately, we do have to keep in mind that on the right-hand side, where we have the dematerialization, material use reduction, waste reduction, all of those factors need to be constantly monitored. Carbon footprint reductions clearly are important now. We have published another paper about a year ago in the Journal of Cleaner Production, which compared the carbon footprint of deep sea mining and terrestrial mining. And no, not much surprise that the oceanic mining comes out better generally for carbon footprint, because you do not have to invest in a lot of the overburden removal and so on and so forth. The big issue, of course, is the biodiversity part. But this is just to show you how, again, a systems perspective necessitates that we look at these different sources and make those decisions on where to mine based on those systems-wide impacts. So if you find an ore body in the Amazon and you have the choice of mining in the Amazon versus mining in the deep sea, how would you decide? And it shouldn't be just about, well, we can do it. It needs to be about what makes sense from a systems perspective. Because just the fact you can do it does not necessarily mean you should do it. And that's a tricky question oftentimes to ask. But once you have that, then you can make decisions appropriately. Because we do need the minerals. And we shouldn't be in this delusion that we can just recycle everything. Right now, we do need this minerals. We need the mining to actually have the stocks, which at some point may lead us to a much more circular economy. And for certain kinds of metals, that may come sooner rather than later. But clearly, for the foreseeable future, we will still need to be engaged in some kind of mining activity. Now, in the UN system, the other way that we have been looking at this in the United Nations is through the Sustainable Development Goals. And this is just to give you an example with the deep sea mining case again, of how you could do an SDG analysis. Sustainable Development Goals analysis for each way in which a metal can contribute to one of the goals. There are 17 goals. These are the ones which are relevant in this case with minerals, just to show you. So for example, life on land is like biodiversity. Goal number 12 is probably the most important one for mining engineers. It's responsible production and consumption. So if you look at the SDG profiles, that's the one you should pay most attention to. But there are other ones which are linked too. So certainly goal number 13, which is climate action, has a direct connection to what kind of metals you're using. But now if you think about artisanal mining, goal number 8 becomes much more salient, because what's goal number 8 is decent work and economic growth, right? Now, would you call artisanal mining decent work? Well, there are indicators under each one to note whether, so you've got the 17 goals and there are over 100 indicators as well, which the UN has come up with to measure what the performance is. Each country has to benchmark their progress from where they started in 2015 when the Sustainable Development Goals were launched up to 2030. So the way the UN works with these kind of large development planning efforts is 15-year periods. We had the Millennium Development Goals from 2000 to 2015. Those were only 8 goals. Those 8 goals were only for developing countries. Now, the Sustainable Development Goals, there are 17 of them, and they are for all countries. The United States also has to report on these 17 SDGs, right? And so this is another way in which mining can be much more engaged with this larger conversation about sustainability and benchmarking. And many mining companies are doing this. We just edited a book with colleagues in Australia on mining and the SDGs, which focuses on different ways in which mining can be mapped onto some of these SDGs. Now, what are some of the frontier areas where we could potentially be looking at some win-win opportunities? And many of you will be familiar with some of these frontier areas. One which I see as very promising is biomining. The reason why it's very promising is because for some of these metals where it is very difficult to create economies of scale, where you have only small amounts of metals needed, as we know with tellurium or gallium or some of these metals which are very small amounts needed, it makes sense to find cost-effective ways like using bacteria or other microbes to extract the metal. And we've seen this now in Canada. It has been, Tech Corporation has been using this more from a cleanup perspective, because they were concerned about selenium as a contaminant coming out of the effluent from the mine. And so what they found was that there are these bacteria which are able to metabolize selenium, and they are able to recover the selenium potentially, which could be used for other uses. We use selenium in different chemical interventions, including for anti-dandruff shampoo, which some of you would know about. But selenium removal through biomining makes some sense in this regard, right? So similarly, there are a lot of these very specialized bacteria which could be further developed. And this is where, interface with the new technologies in terms of genetic engineering, working with a range of what we call chemical evolution. The Nobel Prize in chemistry that was given to Francis Arnold a few years ago at Caltech was around the process of how you can do chemical evolution of enzymes to develop certain ways, selective enzymes, which can help with this. And she was able to do some amazing things, like, for example, actually have bacteria that were able to replace carbon with silicon and some of their core functional structures. So it's very interesting, intriguing stuff that should be pursued. And it's not just Star Trek world, it's happening now. The other area which I see very promising and which can help with the circular economy approach is phytomining, which I hear is something which is being researched in your university, I believe in this department perhaps. this is, and originally when this was being pioneered by Rufus Cheney at the US Department of Agriculture, it was thought of as something really pie in the sky. But it has become much more accepted as an area that deserves attention, not for economically viable extraction of nickel, which that wonderful green sap you see is actually a tree, which is a hyperaccumulator for nickel in New Caledonia. New Caledonia has, very high deposits of nickel. I've had the good fortune of visiting the island. It's a wonderful place. And it's got these trees which have specialized in actually being so tolerant to nickel that their sap is green, as nickel salts are often green. Now, that can be very important for remediation. But for some of these, again, these micro metals, metals which are needed in very small amounts, it could potentially be an area where we could be focusing on rare earth metals or some of these other metals, boutique metals, one might call them, where you could use these plants to be extracting them, especially from tailings and other such geographies. So this is definitely an area which deserves more attention. It's getting a lot of media coverage, but I know a lot of mining engineers who roll their eyes about it. But I would say don't roll your eyes, because down the road, this is the kind of innovation which has the potential to deal with that problem of economic markets not being there for these companion metals. And so that's why I see a lot of promise for this. So essentially, we should be thinking of systems alternatives, which is my main take-home message for you, is that we should be thinking of some of these systems alternatives. We want to, first of all, reduce metal demand. There's no doubt that we want to reduce metal demand overall. So if we can make solar panels thinner, if we can reduce the actual material needed for batteries, that's a good thing. The dematerialization, and mining companies shouldn't feel threatened by it, because you just increase the tail of your product down the road, and you are still being a very good citizen. So I think that's always important. But then the second thing is about switching to products that have more circular metallic flows and finding what they are. So where would we go about that? And so I've talked about the problem with well, I didn't mention thorium, but thorium is another interesting one, that if we were to move to thorium reactors, there has been some analysis done that we would actually not even need to, for some of the kinds of thorium that could be used in reactors, we would not need to be mining more, because we have a lot of that thorium available in existing waste reservoirs as well. So that'll be a very interesting one to look at if thorium reactors move forward down the road. And there's a lot of back and forth on thorium, and it's sort of ad nauseum, literally people debating it, and they are like believers, true believers, and anti-believers. The bottom line is this is an area which deserves research. If you look at the history of nuclear power, and there is no doubt that the reason why a certain kind of uranium reactors were favored was because of the collusion between the nuclear weapons industry and the nuclear energy industry. And because certain kinds of uranium reactors were able to provide plutonium, which was needed for the weapons industry. So the thorium industry was never really given a chance to develop, because it was not going to provide that secondary benefit for the weapons sector. So I see there being a lot of potential for continuing to develop the thorium sector from the point of view of green technology transfer, because for baseload power, I still feel that nuclear has a place, and whether it is different kinds of conventional nuclear move to safer reactors, saltwater reactors, or whether it's thorium reactors, for baseload power, we still do not have a good option in terms of the speed with which we want the transition that people in Glasgow are talking about. So it deserves a chance. And this is an area also where I can go off on a tangent about miscommunication and how science has been miscommunicated in the media, which has led to what people call the social amplification of risk. So people think nuclear power is far more dangerous than it actually is. But we can talk about that in Q&A if you want. But it's one which deserves, again, a systems perspective requires us to think through that. Then the other aspect is, switching to products with organic inputs that can be cultivated. Maybe it's possible. I found out that Gabon, the African country of Gabon, is building the world's tallest timber skyscraper, because they're known for being very rich in timber, and they've got a lot of oil wealth that they want to put to some interesting boutique projects. So let's see where that goes. But their goal is that they're not going to use as much metal, and they're going to use timber. And there are some, there is technology around certain kinds of compressed wood materials. I think that's all fine. Let's see whatever wins out in that. I think all innovation is good. And there may be some reduction in need for metals for some of that, but probably we will still need metals in some form or another for sure. There are also these organic radical batteries, which are being further researched and using quinones, and but you still need metal catalysts in them, and it's again an area of interesting research. But again, we need to not plan that it's always going to come through. We know the lead acid battery is still very much in vogue, right? In fact, the demand for lead acid batteries has been going up, even though it's such an old technology, and lead is like a lamentable metal by many standards for toxicity, but it's still necessary. And of course, we are in Missouri, the heart of lead mining district for the US. So there are limits to what technology can deliver. Some technologies are really good, and that's why they stay. And that's why the lead acid battery has stayed. So that's how we need to think about it. And I hope that that's what, those of us who are working at the international level are able to communicate to countries. So this is how I'll try to sort of wrap up now to give you a sense of how I see ultimately these kinds of issues coming together. This is from a book we put together a few years ago on Africa's mineral fortune. It's showing you the science policy interface, where science, in terms of geoscience data, in terms of socioeconomic data, is interfacing with on the bottom side is the scientific space, and then the top is the policy space. And we need that interface to be much more transparent and connected. So on the top, we've got all of the issues around conflict. You've got even artisanal mining, we put in there, the formalization problem. We have accountability mechanisms, which are needed, like certification programs. We have now a new certification program that's become very popular called IRMA, the Initiative for Responsible Mining Assurance, that Anglo American and Microsoft and some of the big companies have said they want at BMW. So those are gaining that credibility. And then you have, on the bottom side, you have the industrial ecology, LCA work, the ecosystem service work. That has to come together. And that's the role which people like me play. People like me operate in that interstitial space between the science policy frontier, which I find really exciting. But we also need people working in those other spheres, people like you who work mostly down in those areas where you're doing the hard science and engineering. You need both. And we should have the ability to converse among those spaces. And then how do you bring the entrepreneurs into the equation? So this is another sort of model we developed in a paper called SMED, which is Smart Mineral Enterprise Development. So one of the challenges we see is that many times the green technology firms, the ones down here, they are not communicating with the people who are going to be supplying the metals. So there's a big communication lag between the supply and the demand centers. So what this diagram is showing you is that we need to create an entrepreneurial ecosystem which communicates better between the demand centers, which are these green technology firms, right? And some of that research may be coming from national labs and so on, to those firms which are going to supply it. So you've got the mineral exploration firms, but you could also have recycling entrepreneurs. And this is showing you three ways in which that can happen. You want the private sector engagement. In orange is the private sector. In green is the government. And the black one is what we're calling PPP, the public-private partnership. So this is essentially a model which is trying to connect that supply and demand within the entrepreneurial ecosystem. And you're welcome to read the full paper. I won't take too much time discussing it now. So globally now, the conversation is moving towards how can we put this all together? Within the US government, there's this effort called the Energy Resource Governance Initiative, which was started during the previous administration, but it has continued under the current administration too. You can see they've come up with this website. The US approach has been to figure out a way to work with its allies. And these are the 5 countries that they assembled under that. As the subtext in this is concerned about China, clearly that's why they've tried to put this together, because there's been this fear about China's control over metals, though that needs to be taken with a grain of salt, because so far we have no real example that China, if we really needed to get the metals, they're suddenly going to stop giving the metals. Because remember, in 2012, we had the rare earth crisis when the price of rare earths went very high. And what happened then was, with the reasoning China gave for that was that they had all these artisanal miners in one part of China who were creating a lot of environmental damage, and they shut them down suddenly. And so shutting them down, these smaller mines in Jiangxi province led to a supply crunch, and the price went up. However, China was taken to the World Trade Organization dispute resolution mechanism by the US, Europe, Japan, and China lost the case. What did China do? They lost the case. They complied, actually. They changed their supply practices. And so it wasn't that suddenly Armageddon happened, because they did change their behavior. So I think there needs to be some degree of nuance and care about what we assume is going to happen. And then there are other calls now. Just yesterday, I saw that there's a French think tank which has said we should have an international minerals agency, like we have the International Energy Agency. We need an international minerals agency, which is going to make sure that there is this kind of stability of supply and have the rules of engagement around mineral supply and have much better planning around mineral demand and supply. So these are conversations that are ongoing. So I'll end there with just the links to our website for the Minerals Materials Society program, but also we have this online platform, and you're welcome to sign on to the newsletter. We've just launched this recently called Mineral Choices, and it basically crowdsources information, articles, and short summaries of academic articles for the general public. And you're also welcome to contribute to it if you like, and if you have an interesting article you'd like to share. So I will end there and happy to take your questions. And maybe on Zoom also, there may be some, I don't know.
No questions about this.
There are a lot of
This one over the sun.
Yes, please.
Regional mining districts, the average order rate has to decrease.
Yes.
So I'm wondering what, if there's conversations going on about how people can gain from that increased production waste in other.
Yes, so I mean, I think that this is the real challenge, is that you are getting a reduction in productivity if you think about waste as a material that is not going to be functionally used. However, if that waste can be put to use, then you are still being productive. So I think that this is the real challenge, is how do we find productive uses for that waste, which could be both extracting other metals or using it physically for something else, you know. And we've talked about, like with red mud in the case of the bauxite industry, you've got a lot of other potential uses of the red mud. right? They're thinking of making there's a lot of advanced research around making building materials from that or other things like that. So I think part of it is like functionality is key and finding those other uses for that material. And we should totally encourage innovation around that. What I find is unfortunately that there's this dogmatic sense that if the market is not going to provide that innovation, somehow it's just not there. And that's not, I think it's disingenuous, because there is always going to be a role for the public sector to help with that kind of mechanism, right? So we know that from so much research in terms of innovation, that the best innovations have come from public-private partnerships. But unfortunately, there's a bit of dogmatism on either side. The private sector think, like Apple thinks they are the ones who did all the innovations. Well, we know actually many of the, like the touchscreen technology for our iPhones, some of it was developed at University of Delaware through a company called Fingerworks, which was supported by US government grants. I mean, but all the credit suddenly Apple takes. So, there's a lot of this kind of stuff that you need that interface, and waste is a great area where you can have that.
Let's take one question online. So there's a question online saying, what role do you see for space-based resource production in the future?
Space-based, yes. So I personally think that the deep sea has more likelihood for activity than space in the short term. However, in the long term, there is potential, and I would say we should certainly not rule it out, but I would say the potential for space mining is more so if we were going to have some kind of activity going in outer space itself, rather than bringing it back to Earth. Though there have been some studies which have shown that in particular cases of asteroids, the deposits are so high grade that it would be worth the investment. But at this stage, I think it's more speculative, but I never say pie in the sky. I mean, as someone who has admired H.G. Wells and science fiction and seen so much of science fiction come to reality, I'm not the eye-rolling type. I'm always willing to consider human ingenuity in that way. But you have to prioritize. I mean, if I were to prioritize, I would prioritize deep sea mining more so than space mining.
Thank you, Dr. So here is a scenario. We can liken the relationship between mining and recycling and processing to the present situation we have in the oil and gas industry and the manufacturing of electric cars. So there are people think that the production of electric cars will reduce our dependence on
yes.
Likewise, you can see that.
Okay, it's not
So, more recycling, more processing reduces mining activities, right? So, how do we solve this problem between the mining industry and recycling? The increase in processing and focus on recycling to thereby affecting exploration activities.
Yes. Yeah, no, absolutely. But ultimately that should be the goal. That's why I gave the example of the deep sea mining industry, that they are thinking long term about transitioning to being what we call a material service provider, right? Rather than being just ultimately what people want, consumers want, is the material. Whether you get it from recycling or you get it from a mine should not necessarily matter per se to the consumer. The bigger question, that's why I brought up gold, is what happens to the people who are working in it? It's the same question with coal, right? We're transitioning away from coal. What happens to the coal miners? And we need to work on that with compassion about livelihood transitions. But that's not something new. We have had livelihood transitions in human history many, many times. We do not have chimney sweeps the way we used to in industrial England. We have found other ways of transitioning in terms of manufacturing across the board. Automation has made huge changes in transition of livelihoods. So it requires planning. The biggest threat to livelihoods is actually artificial intelligence, and massive automation that may result from that is one of the major areas. but we have to plan for that as well. So I think your question is two-tier. One is around, well, what will happen to mining? And I would say at some level, mining, we should think of it as sort of planned obsolescence, in the long term, in the very long term, because ultimately we want some level of circularity, right? But in the near term, we will need minerals and we should plan for them. But mining companies can reinvent themselves. Just like Anglo-American, I gave you the example of platinum. They are making money from recycling the catalytic converters. You can have companies which make money from recycling too. And they get into the same business and you create different kinds of livelihoods from recycling. You create modularity. You create, products are modular and the modularity leads to different kinds of output. So I think that's how we should think of it. The oil and gas industry started to do that. BP at one time, they made the slogan, BP is beyond petroleum. And they said, we will become an energy service company. I wish they had gone down that route. There are examples of business transitions which happen. 3M, do you know what 3M stands for? Minnesota Mining and Metals. It was a mining company which mined corundum in Minnesota. That's how it started. Now they make, Post-its and Scotch tape. But, companies can transform. I worked at GE. Well, my first job out of my master's degree, but between my master's and my PhD was I worked at General Electric. GE started with Thomas Edison and they were making power plants. Then they started selling mortgages. It's GE Capital. I mean, they diversified. So it's possible to transform. Yes, other question.
Yes.
So something that, there's a spell on land, dig that out, control that kind of thing, the water
Mm-hmm. Yeah. Well, this is the interesting thing with the deep sea mining of polymetallic nodules. So there are three kinds of deep sea mining that could happen. Right now, there is no deep sea mining. The only mining we have underwater is the coastal mining that happens in Namibia for diamonds and things like that. But deep sea mining right now is only on paper. And there have been some prototyping. There's the polymetallic nodules, which are in the Clarion-Clipperton zone between Mexico and Hawaii. This part of the ocean which has these precipitated metal nodules, there's a very interesting chemical reason for why they do it, but I won't go off on that. But that's highly concentrated metals. So essentially, you don't have to do any processing. You're just scooping up the nodules and bringing them up. You do the processing on land, and you do not have the tailings issue. The main concern with that is that you will create some plumes of the sediment. So they've been doing studies to see if the plumes will affect marine life. But it's the sediment. It's not any toxic waste, right? And then the other concern is that each nodule has certain microbiota, which are very specific. And so they have to, so the other interesting thing with the sea is that there is the International Seabed Authority that was set up under the Law of the Sea Convention. It's an international body based in Jamaica, which has been around for 20 years, drafting and preparing regulations for when deep sea mining will happen in the future. We have never had that with any other industry, where regulations are prepared before it even starts, right? So that's what gives me some level of confidence. And we do not have anything comparable for terrestrial mining. We don't have an international mineral agency yet, which they're asking for, right? So.
There are a couple of questions online, so let's take those. So one question says, how do you see the cost and affordability of this green transition, considering the scarcity of the minerals and the costs of risk associated with supply chains?
Okay, let me just read this one. Oh yeah, okay, yes. How do you see cost of affordable green? Yeah, so I think the cost, associated with the risk of supply chains overall, you want to diversify as much as possible. So I think the risk of the supply chains happens from lack of diversification. And this is where, certainly we should be thinking of not having so much concentrated supply coming from China. But it should not mean that suddenly we want to shut down that. I mean, because decoupling completely would be not possible, because so much even of the processing refining capacity is there. But you want to diversify. You want to be able to have multiple sources of metals, because that's like for cobalt, we are concerned. 65 to 70% of cobalt comes only from DRC, the Democratic Republic of Congo. And that's a country which is fragile. And so we want to make sure that we diversify the supply. So that will help with the supply risk. Because if something happens in DRC, suddenly cobalt prices are going to go sky high and we won't have much alternative. And by then, if everyone's busy with their Teslas, then what do we do? So I think that's fair, but diversification can deal with that. We also had a nice point of information from Kurt Oakes that 3M is still mining. That's good to know. Roofing granule plants for shingle production near Little Rock, Arkansas. Well, I learned something every day, so that's good. But it's probably a very small part of their business. But yeah. Thank you.
One question about how does recycling, read the question, how does recycling that does not add value to the organization downstream become a concern for the top management in these companies? In other words, for mining companies to move into recycling, if recycling doesn't add much value to what they do.
Well, this is where I said the public-private partnership is important. Government subsidizes different things all over the place. We subsidize agriculture first and foremost, but we subsidize a lot of other industries. We subsidize hospitals. So this is a case for constructive subsidies. There are a lot of destructive subsidies, but this is a case for a constructive subsidy in the case that, okay, these are metals which are socially important, and recycling and building infrastructure to jumpstart the circular economy is going to be helpful in those countries. So that's one. I do think the same argument was made for, many technologies where once you develop economies of scale, it becomes economically effective. And one of the problems has been also the way in which the companies have been merged and bought. Like I remember there was a company called Noranda. It was a Canadian company. You may be familiar with it. There was a town in Quebec called Noranda or something. But that company was, it was a very circular economy company. They were mining metals, but they also had an electronic waste disassembly plant in Providence, Rhode Island, where they were taking metals out of motherboards. But then they got bought by Falconbridge, and then they got bought by, I don't know, Glencore or wherever, and all the mama companies, and then finally this little thing became nothing. Now, that's where also a constructive role for, socially beneficial companies should be allowed to flourish and that's where you need that kind of investment. And that, it's not socialism, it's not anything, which we would say as destructive intervention. It's constructive intervention. It's constructive capitalism to get those companies to do what is socially beneficial. Here's another one. Let's see. The one? Yes, please.
So a lot of the mining has moved out of the US because of
regulation.
Ecological valuation and the kind of environmental justice that then follows. Do you see any leveling of the playing field to say we're going to value people's health and the environment? And I'm not saying all mining is detrimental, but to kind of level that playing field a little bit so that it's not so cheap to do rare earth mining in China because they're degrading.
Absolutely. Yeah, absolutely. And I think that's where this International Mineral Agency could provide that. The goal is, now that is happening a little bit through voluntary standards because downstream companies are asking for them. Like BMW is saying, we will only buy metal in this way. So, for example, the Aluminum Stewardship Initiative, which is a certification initiative for the aluminum industry, the largest number of smelters that they are certifying now is in China because the Chinese companies have realized that they're not going to have customers if they do not get those kind of things. So there is that happening. Now, the other point, which is a very interesting one you make about environmental justice, and this is something I say to my friends in the environmental activist community, because when they talk about environmental justice, they are just like opposing mining in the developed world many times in a kind of NIMBY approach, not in my backyard, which means if they don't allow mining here, that means it's going to happen elsewhere where there may be poorer governance. So I actually turn their environmental justice argument on its head, and I show it back to them. And I say, and I was in Alaska in May visiting a small town called Haines, which is looking at mining nearby. And I mean, Alaska has a long history of mining, so it's not new to them. But this new mine has created a huge conflict because you have all these retirees from Seattle and, all people who love living there and the fisheries and all that, which is great, but they're just opposing it. And I said, okay, just think about it. If you oppose it for good reason on technology is not there, but think about it also in terms of if you are going to be completely opposed to it, that mining will go somewhere else. So I would say if there are some risks, why not you also bear some of the risk? And not let someone in Ghana bear all the risk, right? So it's an environmental justice argument. Everyone should bear the risk.
And that's my point. Is that
Yeah, exactly.
push their standards up a little bit.
Yeah. And that would be much better. I mean, I think certainly the rare earth mine in California, Mountain Pass, I think that argument should be made for having more capacity for it to reopen. And there is a lot of the NIMBY problem, which we see. Yeah. Other questions? Yeah.
Okay, so from what is with the like talking about is it work to say like a main bill you see any say mining or landfill from our landfill and never to actually reduce them rather than just slow down the landfill.
Yeah, so landfill, so waste recovery, huge imponderable, because there has been also a lot of, unfortunately, the recycling industry has not been entirely sincere with us. They have been very clever in branding things as being recyclable when they're not actually recyclable functionally. They may be chemically recyclable, but the equipment is not there to actually take them out. And plastics is a classic case. Plastics is really, and at the UN right now, there are movements to have a new treaty on plastics because the problem has become so huge. So they've made consumers think that everything's okay because it's got the little symbol on it. And so then what ends up happening, stuff ends up in the landfill. So first thing should be, if we say something is recyclable, we should have the infrastructure to actually take it out before it gets to the landfill, because it gets to the landfill, it's too late. Now, in the developing world, there's another very interesting phenomenon of there's a whole system of waste pickers. I mean, I always say, the people in the developing world were the first circular economy practitioners because resources were scarce. Everyone was going around. I remember as a child in Pakistan, we always had this guy come on a bicycle every week, and he would just be saying, okay, bring us all metal scrap, this, that, give it to me, and we just give it for free, right? So this has always been before in the developing world. There is a whole group of people who are waste pickers who go and collect waste, because they know that there's a market for it and so on. So there are people who do that in landfills, sadly, which is a huge hazard. And we have had terrible incidents. In Philippines, there's a landfill where Manila's big landfill, where there are literally thousands of people who live around the landfill and they go to pick waste. And so, if that could be formalized with safety, I think that would be a way to provide livelihoods. But right now it's anarchy. And, there have been terrible incidents of people dying there. And so I think the landfill issue is there. Now, the third way is to have the leaching of the metal. So you use the chemically take out the metal from the landfill, right? What's coming out from the discharge or other ways in which you could extract it as well. But that is trickier, but it has been looked into. Okay. Questions? So let's see. Someone else. Okay, yep, no, that's fine.
I have a couple of questions.
Yes,
I
sure.
have left my question.
Yes, sure.
So you made the comment about the disconnect between gold exploration dollars, for example,
Yes.
and or even gold, how much of the proportion of exploration dollars gold takes. And I would even add, if you add just gold, zinc, and base metals, essentially,
Yes.
it takes up about 75% of all exploration dollars. For those that are not familiar, when mining companies spend money on exploration, that's their view of what the future means. Right? If a mining company is spending money on gold, it means they expect it to make money on gold. That's why they're spending money on exploration. So the disconnect there is for the green transition, we're saying we need all these metals, but mining companies are spending their money on finding a different set of metals. To me, that says the mining companies don't see the value.
Yep.
In the bottom line, in providing what society needs. They just don't see the value in them. So clearly that's a role for the public sector.
There is.
Why has that not
But
happened?
that has been, the reason why China has succeeded so much in dominating mining is because the public sector is involved, right? We used to have a Bureau of Mines. We don't have Bureau of Mines now in the US. Public sector involvement in mining has diminished dramatically in the US, particularly. Countries like Japan have organizations like JOGMEC, which help with mining exploration, and they subsidize exploration activities. They work with companies like Mitsubishi and all to, resource metals they will need downstream. So absolutely, it's a classic market failure. If you do not have this kind of, and this is what I keep saying, because I'm very conscious of people can easily misrepresent this as government interfering. This is not government interfering. It's just government coming in to play a role which even the most orthodox capitalists would want it to play. So I think that's one way to do it. The other thing is, I would say there is a place for also for some level of philanthropic investment to go into this. And there are like multilateral donors, trust funds which have been set up. They can go into, we have like for diseases, we have the Global Fund for Tuberculosis and so on. These are large funds which have been set up for the public good by philanthropists. Elon Musk tweeted yesterday, he'll pay $6 billion for world hunger if they tell him how it'll solve it. Well, he's into this whole space. Why doesn't his net worth is 325 billion now? Why not think about having, if he wants to do philanthropy, this is an interesting one to put in we will strategically source those kinds of investments. There's nothing which would say you can't run a technology enterprise as a nonprofit. There's no reason why it couldn't be, right? So I think that's another innovative approach which could be looked at. Because we are spending too much on philanthropy sometimes for service sector. We are doing capacity building, we are doing training and these huge philanthropies. Why not do something which is very tangible, right?
I think that my last comment related to that comment or question is, I think the US public and probably one could say the developed world as a whole, the public has been convinced that these materials can be sourced from some other place.
Yeah.
Mining is bad, so it can't be sourced from mining. We want to get it from some other green space, to the point where particularly younger people that are interested in making a difference don't actually think the difference can be made providing materials, because materials and extractives are bad in and of themselves.
Absolutely, yeah. I think this is mining, some surveys indicate it's more unpopular than the tobacco industry, which is really shocking to me, given that we need the minerals are so essential for our lives. So there is a definite PR problem that mining has had. The media is to blame for that. There's no doubt. And a lot of my altercations on this often are with the media, that they misrepresent information. So we need a much better communication strategy which lays out that circular economy is our goal, but to get to that, we still have to mine. And what do we need to mine, how we do it? There are ways to do it which are very well established. There are ways in which mining communities can transition to non-mining livelihoods, but you need the natural capital to get to that point. I mean, I tell the San Francisco people, well, you know, it's like, well, why San Francisco exists? California gold rush, right? Now they don't mine gold, but it started from that. And, you know, university like Stanford, with Leland Stanford Jr. made most of his fortune with the California gold rush, you know, doing shady dealings on transport back and forth. And then lo and behold, you know, sadly his son died and he said, what do I do with the money? And he said, I'll start a university. That university is what created the entire sort of IT ecosystem which developed around it. So there are these spillover multiplier effects of mining which cannot be neglected. And that's also something that people have to realize, that ultimately, even to get a service sector economy, you need some capital transformation. And that usually comes from some natural capital transformation to financial capital. Okay, other questions? Anything else on online? Let's see.
If there are no questions, thank you very much for the presentation.
Okay, thank you. Thank you.
Yes, I'm going to stop there. Yeah, no, we picked at 58. Yeah, I was very surprised.